Hi, everyone. So, yeah, gaps in the things we don't know about how Google works, which is basically everything, I think. So I'm going to take you basically from how some of the stuff that Google is doing with machine learning is making it harder and harder to figure out exactly what they're doing at all, and the ways that they probably don't even necessarily know. And some of the myths about how overconfident many of us have been in how we think the algorithm works, how it used to work, and how it works now. And the experiments that we've been running that show, that highlight those gaps and those flaws in our logic. And there's some areas where computers are probably already better than us at some of this stuff. And by looking at that in a bit more detail, I think we can get some clues about where those gaps are and what Google is doing that we can't see directly. So this talk today is actually the sequel. This is the second in the series, so a talk that I gave a couple of times in America and once at Search Leads. So if you were at Search Leads, you saw the prequel to this talk. If you weren't at Search Leads, don't panic. You can catch up on that talk on our website. All these slides are, I've just tweeted out a link, so you can download the slides and they've got all the links and so forth in them. But I'm just going to recap that quickly. So this is kind of a recap of part one, in case you weren't there, so you're ready for part two. If you're at Search Leads, you can have a quick nap and or check your email. I'll just be as quick as I can getting through the background that you need to get into the second part of this. So Google's algorithm evolved from, there was the PageRank stuff that was their original mathematical breakthrough. Tons of information retrieval theory. Obviously, there were already search engines when Google came along. They used all that best practice stuff, all the things that people had discovered. They discovered a bunch of their own things, actual hard mathematical stuff. But then they layered on tons of tweaks over the years. And that's the bit that I think is too often missed. There's kind of a lot of stuff in there that there's no rhyme or reason. You can't explain why it is. It just works better that way. And if you want to know more about that, you should check out this Hacker News thread, which was on the announcement that Amit Singhal was leaving Google. This was 18 months, almost 2 years ago. And the Hacker News thread was fascinating because this guy, Kevin Lacker, came out and left a bunch of comments on there talking about stuff I'd never heard before. He talked about his experience of working with Amit and how Amit had encouraged him to make changes to the algorithm that they couldn't say why they were doing them. It just turned out they worked better. And this was kind of, he kind of describes the mental process he had to go through to get his head into this space, because he was a kind of pure mathematician who wanted this stuff to be logical and reasonable and theoretical. And instead, Amit was like, nah, do whatever, just if it works well, let's do that. So they layered all these tweaks on. This is before even all the machine learning stuff. They were just layering tweak after tweak after tweak. And you end up with this kind of hugely high dimensional function, right? They've talked about the few hundred plus ranking factors, and it's nonlinear, it's discontinuous. It basically means it's something you can't do in your head. And it's tempting to think that we understand, because we know what some of the ranking factors are, it's tempting to think that we know how the ranking factors fit together and how they work, but I think that's really not true. So just a simple example, you can think of, even if there were only 2 ranking factors, right? Imagine there was only, how relevant is the page to the query, literally keyword match type relevance, and how authoritative is the domain it's put on. Right? Imagine there were only those 2, and you're trying to rank just 2 pages. You're trying to rank one page that's really relevant and quite authoritative, and one that's quite relevant but really authoritative. We'd probably have disagreement in this room over which one you'd put top. It's hard with just 2 ranking factors. It's exceptionally hard with a few hundred ranking factors. Right? We can't do this stuff in our head, and it's getting harder. This is Sundar. Sundar's the new, well, not that new now, CEO of Google, and he's a machine learning advocate. He's kind of pushing machine learning out through all of Google, and he's aided by the new head of search after Amit is a guy called John Gianandrea, who used to run the machine learning team at Google, now runs search, and this guy, Jeff Dean. And in my prequel deck, there's tons of stories about Jeff Dean. I haven't got time to go into them all now, but he's a bit of a legend inside Google. And if you want just one of them, you should go and read this article that was in the New York Times magazine a little while ago now, telling the story of how Jeff Dean plus 3 engineers spent 1 month rewriting the Google Translate backend to use their machine learning tech. And in 1 month with 3 engineers, they got better results than Google had got with a decade of hundreds of engineers building Translate. Not only was it better, the difference, the improvement they made, was a bigger improvement than Google had made in the entire preceding decade. In a month with 3 engineers. Partly that's down to Jeff Dean being just Jeff Dean, but partly it's this machine learning tech and it's taking over Google and it's making this whole thing harder to understand. And so I've run this experiment a few times. I'm not going to actually run it today, we don't have time, but I was going to tell you about a thing I've done a few times when I've been giving the prequel talk, which is people think they're still pretty good at this, right? We're like, no, we're professionals. Right? We're professionals, we know how to do this. So I've run this little experiment where basically I show people a couple of different pages that rank for a query, and they both of these pages rank in the top 10 for the query future of TV advertising. Both these pages rank in the top 10. Give people a bunch of metrics about them and get the audience to say, everybody stands up and it's like right hand if you think page A ranks better, left hand if you think page B ranks better. We do that a few times. By the time we'd done it 2 or 3 times in Leeds, 800 people are sitting down and there's only a handful of people left standing. So we're not as good at this as we think we are, and actually we're pretty bad at it. So we've run a bigger study of this kind of thing. So we asked, obviously when you're doing it in the audience, you only get a very short time to look at it, you're not actually looking at the page, you don't get to look at the code, etc., etc. So we ran it where people are at their desks and they could use their regular toolkit, right? So they could use whatever SEO tools they wanted and take as much time as they wanted but answer the same question for a whole bunch of different queries and sites. The only rule was they weren't allowed to actually do the search on Google, because that's obviously cheating. That kind of gives you the answer. But anything else was fair game, so they could use any of their tools. And as you'd expect, people with no SEO experience were not that great at this, right? They'd get 40-something% of them right. Remember, you're just saying, does A rank better or does B rank better for this particular query? And always, A and B both rank in the top 10. So there's no spam kind of involved in this. The good news, anybody who's employed in any kind of search type role, the good news for you is that you've got a little bit of experience, you are probably better than a layperson. So people with up to 3 years experience did do a little bit better. And those with over 3 years experience did even better than that, so you're justifying your higher salaries, except for the fact that you all lose to a coin flip. Everybody somehow is doing worse than 50% on this. So this isn't great, right? Like, we're supposed to be the professionals here. And this is basically the same problem as optimizing a site. Because answering the question of which of these 2 pages ranks better is very similar to the question of saying, I've got a page, if I make this change to it, will it do better? Right? So you're kind of answering the same question. This is our job. So because we're going to get into some technical stuff, I'm going to talk about machine learning and TensorFlow and things like that, and it's all going to get fun and technical. I've also got a few points where you can just tweet out some stuff. So these are the actual points I'm trying to make in the presentation. If you want to let the machine learning stuff wash over, this kind of stuff. So average SEOs are worse than a coin flip at predicting if one URL will outrank another. Bad news. Good news is there's some technology that helps. This is a sneak preview. So this is basically where my Search Leads presentation ended. It was talking about the fact that we've built this prototype thing. It's not really a product. It doesn't. I'm about to explain all the ways it doesn't work. But on this particular problem, it gets the same question right about 2/3 of the time. Right? So better than even experienced SEOs. So if you had your little nap, if you're at Search Leads, time to wake up, feel like a hypnotist or something, wake up. Right, so this is now the sequel. And what I want to do is tell a bit of the backstory. So a bit of the stuff about how we've built this prototype deep rank thing and what we've learned doing it, even though it isn't a fully productized thing yet. So evidence suggests that the Google algorithm is already too complex for people to understand, and this is the chart that explains that, but there's a lot that goes behind it. So this story starts on a train. This is the Thames Link. This is the train I get to work every day, and it's like a 30-40 minute train ride. And this is the bit of time in my day when I sometimes write code. So I'm not really allowed to write code at work. I never really was, if we're honest. I'm certainly not allowed to write any code that gets anywhere near production, but I quite enjoy it. And so, this is a bit of time where I can just do some stuff that doesn't have to have immediate business impact, immediate ROI, immediate benefit to Distilled. So I write a bit of code on the train, and last summer I wanted to learn a bit of machine learning. So I've been reading about TensorFlow and all the the tech coming out of Google and these open source things that made it supposedly really easy to do machine learning. And my maths background is a little bit overlapping with this stuff, so I was kind of interested in it and I wanted to give it a try. So downloaded TensorFlow, step one. Quickly discovered that this is really complicated. And so actually stepped up a level to a platform called Keras, which is still quite complicated, but it's basically like a wrapper, a framework for using TensorFlow or other machine learning libraries. But it's a little bit easier to write the code in it. And I recommend starting here if you've got a little bit of Python background and a little bit of maths and you're kind of interested in this stuff. And started hacking together this deep rank thing. It's basically trying to work on a problem that I understood. Well, I thought I did. At least understood the question, which was, you start out with these machine learning platforms, and they give you all these toy problems, right? They're like, oh, can you classify? It's like GCSE biology. It's like, can you classify flowers by the lengths of their petals and all this kind of stuff? And it gives you a data set, and then your machine learning has to try and figure out the answer. But I wanted to work on like an actual problem, albeit a somewhat toy one. And so what I picked was this question of, could I figure out which page should rank better based off SEO type metrics? So this is the question we really wanted to answer was, how good is this page for this query? Right, this is one of the pages we saw before. This is on the Content Marketing Institute. It ranks for future of TV advertising, somewhere in the top 10. The question I really want to answer is, how good is that ranking? How well should this page rank? But that's a really hard question to train a machine learning model on, because if you think about training it on Google data, we don't really know how good any of these results are. Right? We know what order they're in, but we don't know whether the third result on this page is better or worse in terms of relation to this keyword than the third result on a different page for a different query. Like, we have no idea. There's no, it doesn't give you a kind of relevance score back. So it's quite hard to train on that. So I basically stepped back to train on a slightly different problem, which is the one that we started with giving the audience, which is, here are two pages and a keyword. Is it A then B, or is it B then A? Like, which page ranks better? Which is a much simpler problem to give the computer, but essentially generalizes to the same thing. So we have tons of data to train this on, because you get a bunch of keywords, pull down the rankings, and then you can take all of the pairs. Right? So you can take 1 and 2, 1 and 3, 1 and 4, 2 and 3, 2 and 4, 2 and 5, and take all of those different pairs. And each one of those pairs is basically a training point for your model. And what we do is we essentially take not just the page, but all of those what are called features in the machine learning world, which is basically the stuff that I was telling the audience about when the audience was trying to guess what ranked better in the game earlier, which is things like domain authority, links to the page, and then on-page features, like how many internal links are there on this page, and how close a match is the H1 on this page to the keyword, or all of these kind of metrics, essentially. Pull those in and kind of feed it into the model. And as I said, this is not trying to detect spam, so I'm kind of leaving to one side the whole problem of people trying to trick this model, because we're not using this in an adversarial environment. We're just taking things that already rank in Google's top 10, so we can let them do the spam filtering. And so basically what we end up with is something where we can give it a new input, so we can say, here's a keyword you haven't seen before. Here are two URLs that you've not seen before. Okay, computer, which one ranks better? And it returns a probability. So it basically says, I'm like 65% sure that page A outranks page B for this query. Making some kind of sense, hopefully? So, but like, what do we do? Why is this? What's the point here? Well, part of the point is we can win party games. I mean, not very good parties, but SEO party games, by being better than the audience at this stuff. But hopefully, if this gets any good, it gets kind of interesting. So I started out building this literally, like I said, just to learn TensorFlow. But if we can get it to good, I mean, imagine we could get it to perfect. So imagine it could say, with 100% accuracy, I know exactly which pages outrank which other pages for every keyword. Then we can use it like an oracle, right? So we can say, before I go and make this change to my website, imagine I've made the change. So here's the original page, and here's the metrics of the page after the change. which one outranks which. And the computer would tell you, oh, that's a good idea because it outranks the other one. Or you could take the people ranking above you for certain keywords and make changes to your page in the model without actually changing the page and see if it skips up their rankings, right? So you could essentially run SEO in the matrix, if you like. And so that would then enable us to search and look for changes, right? You could go and try changing everything and saying which of these things work and which of these things don't. But that only works if the model's perfect. Spoiler alert, it's not. But this is like possibly something that we get to some way down the line. Even before we get to that point, as I kind of hinted at in the title of the talk, what it starts to give us clues about the gaps. Right? So suppose we can get to 80% accurate, like we can get this right 80% of the time, while only feeding in link data and some on-page metrics. That starts to constrain how powerful anything else might be, like usage data, or anything else we might hypothesize feeds into Google's algorithm, but we're not feeding into our model. We're starting to constrain how much of a problem that is and how big of a deal it is and how much difference it makes. Does that make sense? So yeah, we kind of get to start to close the gaps between what we know and what we don't know. But there are a lot of dead ends. We've got to kind of like wade through the forest before we get to that point. So that's the bulk of this talk, and that's where we're going to go on now. So this little journey of basically me messing stuff up and trying to figure out how I'd messed it up. And the first thing to realize is data is actually probably the hard part here. So you always start out thinking that the magic model bit is the difficult bit. The TensorFlow has got big names. I've never heard of this before. It must be hard. That's like way easier than gathering all the data. So Google published a paper called something like, what was it called? Rules of Machine Learning, which is basically like their guide to their own engineers on how you do machine learning. And like 80% of it is about how you get good data and how you make sure your data is good and how you keep your data good and all that side of things. And only a little bit of it is actually how you run the model. And in our case, our data pipeline, it shouldn't be too brittle, but it turned out to be surprisingly complex. So what we were doing was basically grabbing a whole bunch of rankings data. So we use Stat for rank tracking. So we've already got a bunch of keyword data in there, a bunch of keywords we're already tracking, a bunch of rankings we already know about. So we pulled down tens of thousands of rows of data from there. And then for each of the URLs in that data set, we want to pull in some other metrics, right? Other stuff about these pages. So things like link data, obviously, and the Alchemy API was kind of handy for some of the on-page stuff because it could do topic modeling and things like that, but unfortunately it got shut down. So we're trying to replace that with some of our own tech, but it's not particularly effective. But anyway, point being, on-page metrics, like kind of how closely related is this page to the topic, how closely related is this site to the topic, all those kind of hard things. Then we actually crawl the page. So get the HTML of the page that's ranking, and that lets us look at all those metrics I was talking about before, like number of internal links on the page, number of outlinks on the page, how many no-follow links are there on the page, and you get all of the copy, right? So you get the body copy, the H1, the title. You can pull out all these different bits, and you can essentially say all of these different things, how closely do any of them match to the original keyword. And process it with a bunch of stuff. If you're actually trying to play with this, scikit-learn is pretty cool, and we'll talk more about that in a minute. But basically, that's the process, but you're doing it for tens of thousands of pages, and that's obviously trivial for Google to crawl, but it turns out I messed it up in all kinds of amusing ways. So when I was doing this a few months ago, I didn't have this tool, which is Google literally announced, I think, the day before yesterday, and the link's in the deck. I can't remember what they call it, but it's basically a big data explorer. So if you've got tens or hundreds of thousands of rows or tens of millions of rows, you can dump the data into this tool, and there's a hosted version where you can upload a CSV and essentially explore it for anomalies, which is basically the places where you've messed up. So it's like lots of zeros, which probably shows that you've gone over your API key limit or something. Weird distributions that get cut off at certain points. And essentially it should look nice and smooth like that. And eventually my data looked nice and smooth, and I had like decent, you could slice and dice it. And if I'd have had this, I'd have found some of the problems sooner. And so basically with all this data, dump it into this TensorFlow model, and the first thing that we wanted to try and do was, so we have an ongoing argument. Tom Anthony, who runs our R&D team, and I have been debating to what extent Google's algorithm is different in different keyword areas. Clearly, different kinds of sites rank for different kinds of keywords. I don't just mean different sites, I mean like different, it seems like different things are valued in different niches, and there's certainly correlation data suggesting that. So some of the search metrics data was partitioned by industry, and they found different correlations in healthcare versus e-commerce or whatever. My theory is that this is not kind of hard-coded into the algorithm so much as this is emergent complexity of like how the market has become. And it's a bit self-reinforcing because obviously people start to copy the people who do well and that kind of thing. Tom has a theory that actually there are areas where they said, no, we're going to have a healthcare algorithm. We don't know which one of us is right yet, but we keep going. But anyway, so to basically to sidestep that argument, we started out just on a limited set. So we started out with property keywords. Right, so we were tracking a whole bunch of house for sale in place, flat to rent in place, all those kind of keywords, tons of them across the whole country, and gave it a shot. And 90%, it was getting 90% accuracy on telling which page ranked better. Jubilation was quite short-lived because this was basically nonsense. There's no way it could be that good. We weren't giving it good enough data to, you think about the complexity of Google, there's no way we're getting 90%. So it sounded a bit implausible. Turns out, actually, 90% was pretty terrible because I was actually giving it the answer. So my features, one of the problems was I actually had the rank in there. And so I was basically saying, here's a page that ranks 2, here's a page that ranks 4, which one ranks higher? And my machine learning was getting that right 9 times out of 10. So yeah, that was a little bit disappointing. But rather than optimize that, took the rank out, had another go, and 80% accuracy. I'm suspicious. It seems probably too good to be true. But the problem is, it's really hard to know because there's things like a black box. You just put the stuff in and stuff comes out, and you're like, Those are literally the faces I pulled. So, what was the plan? Okay, well, let's try modeling that same data. So we've got this big data set. Let's try modeling it with a much more simple algorithm, right? So instead of doing all that complex TensorFlow nonsense, let's try making a decision tree. So that scikit-learn package, which is just a Python package that is actually turns out really easy to use, can make a decision tree classifier, which is basically just a flowchart. So you've seen these kind of things. Essentially, this just goes, how long is the path, is the first question it asks here. If it's less than 36 characters long, go one way. If it's more than 36, go the other way. And it just branches down. And essentially it gets to the bottom and tells you what it thinks the answer is at the bottom of all this stuff. And there's a really simple API into this, so you just use it, and it generates a picture like this, and it tells you what it thinks the answer is. It also tells you how good it was, so how often it got the right answer on the training data, on the validation data. And in the deck, if you want to download it, it tells you how to read those things. But basically, you take a path through like that. So any one pair of URLs, you take all these decisions, and you end up at a place that says A outranks B. And that was also accurate 80% of the time. This seems really implausible. Like literally 3 steps of decision tree. If this, then that, if that, then this, and now I know the answer. I'm suspicious. This took a little bit longer to debug, but by looking at the decision tree, we basically figured out what it was doing was, so does anybody here work in the property space in the UK? Have you done a bit of work in the property space? Even just as a layperson, you'll realize that the UK property space is dominated by a relatively small number of big players. So you see the same domains ranking for lots and lots and lots of these keywords. And it turns out, about 80% of the time, they rank in the same order. And so you can, the model was just learning which domain it was and saying, well, if it's, if I'm looking at Zoopla versus Find a Property, it's this answer. If I'm looking at Rightmove versus Prime Location, it's this answer. So this turned out to be surprisingly effective when added to some of the other metrics that were in there. So, okay, that was another break in the whole process. So now what we started trying to do was say, let's keep the training data not only partitioned by keyword, so in other words, we're holding back some data to test on, right? So we train on some data, and then we hold back some data to see how good we were. We were splitting that by keyword previously, so saying train on these keywords, test on these keywords. But that wasn't good enough. What we found we had to do was actually hold back some domains. So say the domains that we validate on, that we test on afterwards to see how good we are, have to be domains that never showed up in the training set. Okay, so if we're putting Find a Property into the training set, Find a Property cannot show up in the test data, the validation data that we run it on later to see how well we did. And this started getting much better. The performance of the decision tree and the TensorFlow model diverged, right? The decision tree became terrible, only just slightly better than tossing a coin. TensorFlow ended up, like I showed you on the chart earlier, getting it right about two-thirds of the time. And this is kind of our current state of the art. I want to get it significantly better. I don't think it gets useful until we're probably into the 70s. Like 75 feels like quite, three-quarters of the time feels like it's starting to become something that we can actually use in some kind of diagnostic or whatever else. But what it's already telling us is that we can get to that point with only quite naive metrics, right? These are just a few external link metrics to both the domain and the page, plus a few quite naive on-page metrics, a bunch of like internal link counts and quite naive matches between the keyword string and things like the H1, the path, the title, the body copy, that kind of stuff. Really quite SEO 101 kind of stuff, but it's already getting us better than 90% of actual SEOs. So, there's that. So yeah, our computer models can correctly determine which page ranks better about two-thirds of the time. And this is what I'm kind of getting at, is that I think if we can just squeeze the gray bit, essentially if we can make the model better and better and better, we squeeze the bit that we don't know, so we squeeze the bit that is actually very hard for us to know, things like usage data, right, which seems like we don't know exactly what the mechanism is for the effect there. Is it bounce, like linger time on the site before going back to the search results, that kind of going backwards and forwards between the search results and the results pages? Is it some other kind of data? Is it data Google's buying in? Is it real time? Is it training a machine learning model their end? We don't know any of these things, really. We have kind of little hints and pointers in some of these directions, but we start to squeeze that down. And I think we'll get better at the on-page analysis, and hopefully we will be able to squeeze that down. But it also highlights that we imagine that there's this fundamental limit, right? What we imagine is that by just looking at the page, by looking at its links and its content, we're going to hit a wall. We're going to hit a point where we can't get more accurate than that, because Google is looking at other things. And we have a bunch of data suggesting that this is the case. So this presentation that my colleague Tom Capper gave in the US, but again, the video's online, he's basically talking about some of the correlations that he's seen and some of the data work that he's been doing is showing that it seems very important that links still seem very important for getting you into the consideration set for competitive queries, right? You can't rank with no links for competitive queries. But once you're in the consideration set, in those top few results, the ordering breaks down. And there's a lot of reordering, a lot of testing, it seems, on Google's side, like, do people prefer it this way around or that way around? And the usage data comes into play. And long run, we think that's where it converges, right? Like, PageRank was only ever a proxy. It was never the real thing that Google was trying to measure. They're trying to measure user satisfaction, task completion, intent matching, all this stuff that everything else is just a proxy for. And so we think it kind of converges that way, but we get to start to draw better hypotheses about it. So, breath. That was all I think the maths is done, all the Python and that stuff. But I want to talk about what this is doing to our real world work and how we're thinking about the implications of this stuff. So basically, we're running a lot of split tests, and we built this platform. So has anybody seen the work that people like Pinterest and Etsy have been writing about? I'm guessing some people might not have, but so Pinterest pioneered it, I think, where they basically said, okay, what happens if we give an SEO task to a bunch of engineers? And of course, the first thing the engineers do is start writing code. So instead of just doing what they were told and changing the H1s or the titles or whatever they were supposed to be doing, they wrote a bunch of software that said, what if we only do what we were told on some of the pages on the Pinterest site? And we keep some pages back as a control, and then we compare the performance of the pages we changed with the pages we didn't change, and fancy maths, and then figure out if that was a good idea or not. And they basically made this work. So they managed to start proving what changes were valuable and what changes were not on page. And some of their early results just totally mapped to what an SEO expert would have recommended anyway. But obviously, the further down you get, the more interesting the results get and the more in-depth those things happen. And the big difference between, you all come across split testing, right? So Optimizely, Website Optimizer, all these kind of tools let you do CRO-centric or user experience-centric split testing. What we're talking about here is a little bit different. So with CRO split testing, you would create two versions of your page, and you show half your audience one version of the page and half the audience the other version, and you see which half of the audience converts better, essentially. We can't do that with Googlebot because there's only one Googlebot. So we'd have to either serve Googlebot page A or page B. We can't kind of cloak it or whatever else. So what we end up doing is doing it the other way around. Imagine you've got an e-commerce site with 1,000 products. You change half the product pages and leave the other half unchanged. So suppose you're going to add structured data. That's your hypothesis. Adding schema markup to our product pages is going to make a difference. Just do it to half the pages. Hold back half the pages. Apply some fancy maths. Make a control group. Figure out if there was an uplift or not. So that's the background. We thought this was fantastic. We wanted to be more data-driven like this, but we knew we couldn't convince every client that we had to build this into their core platform like Pinterest does, like Etsy does. I think TripAdvisor has it as well. So we built a platform called the Optimization Delivery Network. If you're interested in that, we can talk about that later. That's not the point of today, but I'd happily show it to anybody who's interested. You can go to distilledodn.com. But the bad news is that the bad news keeps coming. So for us professionals who work in this field and think we know what we're talking about, firstly, the coin toss beat us, then the robot beat us, and now we're going to find out that we actually spend half our time telling our clients to do things that make no difference or possibly make their sites worse. So a few examples of this. The first one is probably not that surprising. So alt attributes on images. This has been a thing that theoretically makes a difference to rankings kind of forever. Like, it's there in the literature. It makes some sense from an accessibility perspective. Search engines can't, I mean, maybe they're starting to now, but they certainly didn't used to be able to see anything in a picture. So it made sense, but we didn't think it was a very strong ranking factor. There's no reason why this would make a massive difference to your rankings. But it's there in the correlation studies. It always shows up that it's correlated with ranking better. But I think this is correlation, not causation. Always did. We proved it. We added alt attributes to half the pages, not to the other half, and a big nothing. So the way you read these is basically the pale blue area is the confidence interval. So the confidence interval is just, we're just getting less and less certain what the result is, but it's going nowhere. A winning test looks like the confidence interval going above the x-axis. So that failed. So if you're recommending that your clients add alt attributes to images, it may very well be valuable from an accessibility perspective. It's a good idea for a variety of reasons, but don't expect a big ranking shift. I'm not telling you anything that most of you don't already know at that point. Unfortunately, we saw the same thing with some structured data. So we've seen some structured data tests that were massively successful, and I'll show you some in a second. But we've also seen some that were just a great big nope, where we added structured data to pages, and I think our hypothesis here is that these pages were already well-structured HTML. So the places where we've seen the biggest results have been poorly structured HTML, where structured data added a great deal of information to the page. The places where we've seen it just go sideways, it's much cleaner HTML, so we kind of suspect that Google was already getting the gist already. This is an interesting one, title tags. So who's done keyword research and found that there's a higher volume way that people search for the thing that you offer, and then said we should start talking about it this way? Well, we did this. This is just an example. It wasn't actually for Argos, but we did this with an example a bit like this, where we went from the low volume kind of search structure to the higher volume search structure, and minus 8%. Two possible reasons. One is we moved into a higher competition area. So we were previously maybe ranking better for the lower volume stuff, and then we ranked worse for the high volume stuff. Other possibility is that this was just less compelling. So it looked worse in the search results. And this is a big thing that we're testing a lot these days, is click-through rate in the organic search results. We do it a lot in paid search. It's been hard to test in organic, but I think that's the other possible thing here, is that the higher volume search term was actually less compelling and fewer people were clicking on it. If only Search Console data were better, we could possibly tell. So we went the other way, right? Instead of saying, okay, let's pick the one that more people search for, we said, well, let's pick the one that more people will click on. I mean, we didn't quite go this far, but not quite as far as free beer, but like a more compelling, more engaging, more like, come here, see my stuff. Nope. So that was all a bit depressing. And if you're not testing, you're probably recommending things that are a bad idea. You're either wasting engineering time or possibly damaging sites. Okay, that's me saying that. But don't worry, we had some success stories. So I need to kind of wrap up and leave hopefully a moment for questions. But I just wanted to end on a little bit of optimism. So we have run some tests that did work. Not everything failed. Most of these I've shown before in one presentation or another, but adding structured data definitely did work on category pages for one of our big sites that we were running it on. We added product markups, saw an uplift of 11%. This was fairly bad HTML before. Adding structured markups saw a significant uplift. using JavaScript to show content. I wrote this up on our site, and I wrote a post on Moz as well about Google claims it can index JavaScript. We had a client where a page looked like this if you turn JavaScript off, looked like this with JavaScript on, worked in fetch and render. In other words, looked like that in fetch and render. But when we removed the reliance on JavaScript, in other words, made it look like that when you had JavaScript turned on or off, the split test showed a significant uplift, over 6% of organic traffic. I have some theories about why that is. Today's not the time. Point being, don't always listen to everything Google says. You've got to test it. I wrote that up there. And yeah, this was an interesting one. So anybody have SEO text on your category pages? You know, that kind of like bit of text where you've ran the keywords in at the bottom below all the products. Sometimes people even put that in like div ID equals SEO-content or something just to make it like really, really crystal clear. It's terrible quite often. It's not written for users at all. We tested removing it. And on the first site we tested removing this copy on just some of the category pages, we saw a significant uplift. I mean, a small one, 3% uplift, but still an uplift, a statistically significant uplift. We did the same on a different site and saw it go the other way. Just showing that how complex all this stuff is. It really depends exactly how high quality that content is, how good the page is with or without it anyway, and a whole bunch of other stuff. And essentially we had to do this testing to get there. And I think that's kind of really the message is, this is why we're investing so much in this stuff, is I think it's really hard to do without, because we can't do this stuff in our heads, as we've proven a few times. So there's a bunch we haven't written up yet. You can follow me on Twitter at @WillCritchlow, and I'll tweet these out when we write them up. Or if you go to the odn.distilled.net page, there's a annoying email drop-down thingy, and we'll email you when we write them up. But we did one, which is unsurprising. British company launched US website without using US words and spellings. We tested replacing them to see how big of an uplift that was. It was statistically significant. We'll talk more about that later. Fresh content, so across massive long tail pages, bunch of updating of content and last update dates, and saw an uplift from that. And the keyword targeting I mentioned earlier, we actually had a successful one where we changed to a higher volume keyword structure and saw a significant uplift from that as well. So we'll be writing those up soon. I'm kind of running out of time. That's a bit more about the, if you want to download the deck, you can see more about some of those things. So recap before questions. We couldn't do this even before machine learning, before Google started using machine learning. 200 plus classical ranking factors. Honestly, we weren't very good at it. None of us were. Machine learning makes it worse, makes it harder to explain what's going on. That's accelerating under Sundar. I think it's our own work on modeling the algorithm that helps us figure out where the gaps in our knowledge is and helps us point us towards things that might be successful. But ultimately, we're only really going to know by split testing on our own sites, because if we're not, then it's very likely that we are wasting engineering time and doing things that actually move the needle the wrong way. That was kind of a lightning quick trip to the end of it, but hopefully we've got time for a few questions. Thank you.
Yes, any questions from anyone? Yeah, give you the mic.
Are there any specific split testing tools that you'd recommend?
So there aren't very many that do SEO split testing, and ours is the only one we've used. Obviously we have one, so that's the only one I can talk about how it works. Basically, the problem is that you need to be making server-side changes, and you need to be changing an arbitrary percentage of an arbitrary section of your site. So if it's adding something like structured data to product pages, you need to be saying, can I just add structured data to 10% of my product pages? And for most people, that means involving the engineering team. So the way our stuff works is it's like a CDN, so it deploys as like a proxy layer, typically inside a CDN if there already is one, and can basically make those changes in a rules-based way on the fly. So essentially, from the outside world, from the user's perspective, it's exactly as if you'd changed it on your server. It's in the HTTP response, but you don't have to go and get your engineering team to do it. So.
Hi, man. Have you looked at the value of influence that each one of those factors has in the training data, in the sense of what is the relationship between a link and all of the factors?
The short answer is, well, so I started trying to. I kind of ran out of time a little bit. The very first naive thing I did was literally just look for what happens if I make big changes to any of these numbers. And the answer was basically you need more links. Like the dominant factor was like, yeah, ramp up domain authority or something and you rank better. But no, I haven't done the kind of gradient descent of like which one is more valuable. I don't know if it's going to give us very interesting information until the accuracy is better. Because remember, it's only getting 2/3 of them right at the moment. So I don't know how good that gradient is. But yeah, that's another thing that I want to kind of have a play with.
Any more questions? Yeah.
How do you feel that the SEO sort of landscape is going to sort of pan out when we can't essentially say whether a particular strategy is going to work?
I think it will look more like the CRO landscape. So if you've ever done the, I've forgotten the name, somebody might be able to remind me, there's a name of a site where you can basically go and try and guess which CRO tests win. Does anyone remember? What test won? You go and do that, you find you're not very good at that either, as in like, do people convert better on this form or that form, those kind of things. And essentially the CRO process ends up looking like a bunch of user research, a bunch of market research, a bunch of some best practices, but then ends with testing. And I think it's a similar kind of outcome.
Do you think that based on us not being able to sort of definitively say that sort of people should I don't think anything's going anywhere. It just changes all the time, doesn't it? I mean, people who were employing 200 guest bloggers at one point, or sending all their money to directory article spinning, whatever, are doing different things these days. I think it'll just continue to evolve. In particular, I don't think search is going anywhere. So, in fact, at MozCon, I think yesterday, Rand shared a bunch of data from JumpShot, which is a company that buys aggregated ISP data, and it showed just quite how dominant Google is in sending traffic out to sites. So, people talk about the rise of Facebook and all this stuff. Like, Google is still massively dominant in the source of traffic across most brands, most kinds of sites. It's not true in breaking news, where social is huge, but in most verticals, Google is still massive. So I don't think search is going anywhere. Somebody's got to rank better than somebody else. I think there's still a job for us in helping them do that.
Thanks, guys. Thank you so much, Will.
Thank you.
Give you a round of applause.